So I'm gonna assume I'm not saying that there's something wrong if this isn't true for you, but I'm gonna assume that you mostly didn't have any questions with 1 through 7. That is not to insinuate again that you're like dumb or something. I just think those are the ones that were probably more in your wheelhouse. Starting on number 8, I threw a little tricky at you. So let's go through number 8 first of all. Yeah, so this is from the practice quiz, problem number 8. Um, and right away, I threw something at you that you're not used to. I am, instead of copying the problem down directly, I'm going to go ahead and move that 14 to the other side. Because even without me going over this, you know that that's the first thing to do. So the right side is now going to say 6x with the 14 moved over there, so minus. So even though I've never given you one exactly like this, I just thought, let's see what your instincts tell you. What should we do first? Right. And I went out of my way to make sure that the numbers over here are both divisible by 2. We just listen, you're going to hear this week and then in the coming couple of weeks when we get to the harder inequalities. The theme is get the absolute value by itself. No matter what else you do, you can't go on until you get the absolute value by itself. So in this case, that means that we have to divide by 2. So when you divide here by 2, you have to also divide here by 2. And what happens is then you get the absolute value of 4x minus 7 is equal to half of both of these, which should be 3x minus 7. And that really is the only newness with this particular problem. There's also a little bit of no, that this one's pretty straightforward. Let's finish it though. Let's make it official. So remember, this does not count as one of the 2 equations that we write. So sometimes people try to use this one and solve it. I want to say this, you cannot solve that equation. Okay? You must create 2 equations by law that do not have the absolute value sign on them. So one of them is, I get it, basically a carbon copy of what you see. You take off the absolute value signs and then essentially just copy the problem down. That's a solvable equation now because it doesn't have absolute value. The other equation that we create is the stuff inside doesn't change, but we negate both parts of the right side. So 3x becomes negative 3x and minus 7 becomes plus 7. So you have to create both of those. And then from here, it's really just a basic sort of algebra 1-y sort of vibe. On this one, I'm going to subtract this 3x across, giving me 1x. And then I'm going to turn around and add the 7 back across, giving me 0. And that's one of my potential answers. On the purple one, I'm going to add this 3x across, giving me 7x. I'm going to add this 7 across, giving me 14. And if 7x's are equal to 14, then x by definition has to equal 2. So the thing with this quiz is that you've got to make a choice. And, the choice is, should I put a box around these or should I put a cross through them? And how we figure that out is we go someplace. This is really important that you have to go someplace above this yellow line. And it can be directly above the yellow line or it can be a little bit further up the way. I prefer to always use the one that I've worked on. To me, I choose this one because to me it feels the cleanest and just nicest to work with. You can substitute your answers anywhere above the yellow line. Okay. So I like the one that I put stars by. So if I put 0 in place of all of my X's, I don't even really need to do any work because where this green arrow is pointing here tells me all I need to know. What is right here 3 times 0? And what is 0 minus 7? And remember that the absolute value can never, I don't take that word lightly, it can never produce an answer of negatives anything, or in this case, -7. Therefore, 0 is not a valid solution. You don't need to do a whole bunch of math. Oftentimes, it's just going to pop out at you. That's the benefit of using the equations later down the line. I think they're easier to see that. And then if I put 2 back in place of where the green arrow is, again, I just do some math. 3 times 2 is 6, and 6 minus 7 is negative. And again, that's a deal breaker. So this one also gets crossed out. And the answer then to the problem is that there is no answer. That's what we put a box around is the no solution. That is our statement of finality. We had two candidates, but they both did not work. And there you go. Okay. Not that bad. Let's take a look at number 9. And in number 9, we're going to have to contend with some fractions, and I'll try to show you that they're not as scary. They're still a little bit annoying, but they're not maybe as bad as we think. I am, again, not going to copy the problem down. I'm going to copy down a version of it that does not have the 1 in the wrong place. And so I'm going to add the 1 across to the other side, giving me negative 4x plus 1. So regardless of the fact that there's a fraction, that shouldn't alter what we do next. What we do next is robotically programmed into us. We know that we have to do our due diligence and make two versions of this equation. So one of them, as always, is essentially a carbon copy. We just take off the absolute value. The other one starts out as a carbon copy. The x plus 3 or x over 3 plus 9 doesn't change, but we again negate the entire right side. So negative 4x becomes 4x and plus 1 becomes minus 1. So back in Algebra 1, for a couple of you, it was last year. For most of you, it was a few years ago. I taught you how to kill fractions. And so let's bring back that old skill from the past. It's been a hot minute since we've done it, but these equations make us uncomfortable by nature, all mathematicians. Rarely does anyone go in there and like turn negative 4x into negative 12 over 3x and then add that and get 13. Like, that's just not what we do. One little thing that I gave you, a little treat, a little tool, is the ability to make equations not have fractions. And that's the first thing we ought to think in both of these is let's make our lives easier by getting rid of the fractions. So we have to multiply by 3. And the reason we do that is because where this yellow arrow is pointing on both of these is going to produce a result that we like. What happens when the 3 multiplies by x over 3? The 3's cancel, and we're left with something that's not a fraction. The trade-off is we have to not be boneheads. We also have to remember to multiply the 3 by everybody else. Fair's fair. So if you treat one part of an equation a certain way, you have to treat all parts the same way. So as I distribute my 3, I'm not getting any closer to solving the equation. This step, some would tell you, is a waste of time. Those people are crazy. It's just I'm getting this to be without fractions. And so I wind up with regular 1x plus what? 27 equals what? Nice job. So we basically just buffed the whole equation times 3. If you triple every term in an equation, it's totally legal, but the payoff is that you don't have fractions. Let's do it in the purple equation as well. What do we get on the right side for the purple? X plus 27 equals. Nice job. So again, that step, I get it, is a waste of time, but it's a worthwhile waste of time to me because now I've got just, easy peasy. So for the red equation, I'm going to add the 12x across with his friend, and they're going to make 13x's. Then I have to subtract the 27 over with his friend, and 3 minus 27 is negative 24. And I wind up with my first candidate, x equals something that I'm not particularly familiar with, negative 24 over 13. It's just about negative 2. It's like negative 1.8 or 9 or something like that, right? Close. And then for the purple one, again, just algebra 101. I'm going to subtract my 12x across, giving me negative 11x. And then I'm going to subtract my 27 across, giving me negative 30. And then I'm going to divide by negative 11, giving me my second candidate, which is positive 30 over 11. So here's my advice to you. You don't actually have to do a ton of real mathematics. Here's the thing you're going to find with absolute value equations is when they don't work, it's because negatives are the things getting in the way. It's usually not because the math doesn't check out. It's just because something happens where you get the absolute value equals a negative. So let's employ some real simple common sense here. And I can show you, we can actually go through and do all of the math. But the math we really need to focus on is putting our candidate, the first one, the red one, of course, is a negative number. And what happens if you put a negative number where that green arrow is pointing? Yeah, I mean, that's just eighth grade math 101. A negative 4 times a negative something is a positive. And what's a positive plus 1? That's a positive. So negative 24ths is negative 24/13 is going to pass the test. He can have a box. He is a solution. You don't have to go plug it in everywhere unless you really want to verify that the numbers actually check out. Like I said, we just want to make sure that we're not going to break that law, that we're not going to get absolute value equals a negative. And again, I think I can say that I mean, I can't imagine that you need a calculator to reason through this, but take the purple number 30 over 11 and let's round it. You would agree that if you had 30 and divided by 11, isn't that pretty close to 3? Like, so let's ballpark it and just call it about 3. It isn't perfect, but it's going to work for us. If you put something that's about 3, where that green arrow is pointing, what's negative 4 times 3? Negative 12. And even though it doesn't quite get to negative 12, it's probably like negative 11 point something. But here's the deal. What's negative something like that plus 1? It's still going to be a negative, and that's all I need to see. So the math doesn't have to be like, I don't have to go through and check all the tiny little calculations. I know enough here to know that if I put the purple number into this purple egg, the purple egg is going to be a negative answer. And I know that the absolute value is not going to equal a negative. Therefore, 30/11s can take a dirt nap, and there's only one solution. Okay. So don't be overly intimidated by the fractions. Just reason your way through them. Okay. And just ask yourself, am I going to break the negative? That's going to get you by. Easy peasy, huh? Okay, let's take a look at number 10. So in number 10, I have a lot of prep work for you to do, and I'm going to copy the original problem down this time. So this is number 10. And we have 8 minus the absolute value of, I really don't care at this point in time, minus 2 equals 5x. What's inside the absolute value will not matter for the next minute or two. It doesn't matter. So what we got to do is do all the work on the outside. We got to get that absolute value so that it's ready to go to Splitsville. And so the thing I don't know. Well, let me ask you, did anyone notice something about this? Something before that? You got to kind of, you're still not seeing it. Common terms, like terms. Very good. So what I was interested to see if you guys would spot this. And if I ever throw something like this at you, you should just go back to basic algebra and just say, wait a second, I've got two like terms on the same side of the equal sign. What is 8 minus 2? Correct. And so what I can do right now is actually replace both of those yellow circles, or they're not circles, but those yellow blobs, I can replace with the number plus 6. So I'm going to recopy the problem now as the negative absolute value of I still don't care plus 6 equals 5x. Got it? But I'm not ready yet. I still haven't made it to Splitsville because I don't have the absolute value by itself. So I've got 2 steps now that you should be familiar with by now. What are the 2 things I have to do to get ready? Subtract the 6. Perfect. So I'm going to go ahead and show the steps just because I'm recording and I want to make sure that everyone's on board here. But the next step would be to move the 6. If assuming you did your delta math, you've done a lot of these. Like we know the drill. So we move the 6. So we have the negative of I still don't care equals 5x minus 6. And I will not write I still don't care anymore after this because now I need to go back soon to acknowledging what's inside so that I can construct my math problems. But like Mari said, the last step now is to divide away the negative. And that's going to get us to the crossroads, the place where we need to get with every single problem. So we're going to have the absolute value of 3x minus 1 equals negative of 5x and negative of minus 6, which is plus 6. This is the work, right? I feel like these problems have two phases. Phase one is pre-split, and then phase two is post-split. Pre-split is just as important. Getting the absolute value by itself is massive. And like in this problem, it took a bit. Sometimes it's pretty easy. That was a little rougher. So now we're going to do Splitsville. So we're going to say on one of our equations, the absolute value of the stuff inside, or excuse me, just the stuff inside, equals exactly what I see on the right. Bless you, negative 5x plus 6. The other equation is going to come from stuff inside, unchanged, equals the negate both halves of the right side, equals positive 5x and minus 6. So after this, I'm just going to finish with you because we are again going to be faced with fractions, but we can reason our way through the fractions. It's not that bad. So let's do the basic algebra. On the red equation, I would move the 5x over, giving me 8. And then I would move the 1 across, giving me 7. And then I divide, and I'm not going to put some 0.875 nonsense. We know that x just equals 7 over 8. The rule has always been that if we can't divide, we just don't. We just leave it as a fraction. And on the purple equation, I'm going to move the 5x over to the left, which is going to make 3 minus 5 is negative 2. And then I'm going to add the 1 across, and negative 6 plus 1 is negative 5. And then I'm going to divide by negative 2, which is going to give me x equals 5 over 2. So we have two candidates, but again, I feel like we can reason our way through this. And your calculator can help you. You'll probably want it. Some of you probably more than others, I would say. But at this point, we have to go through now and vet these things. And I'm telling you, like I will tell you every single time, I will always use the equation that is the sweetest and cleanest version of what's above. That to me is always going to be the last one. So you do you, but that's the one I'm going to use. As long as it's before the split, it's good. So if I put, and I'm not interested in what's in the absolute value. I tried to make that clear on the last one. What I'm interested in is if you see this green arrow right here, I want to put my numbers in there, and I just want to see what the right side comes out to be. The right side comes out to positive, I'm going to assume all's well. If it comes out to a negative, then I'm going to say you're no good. So if I put 7/8 in there, any thoughts on that? Well, I agree that the green egg is going to be a negative. And this is where, again, some of you will be into what I'm about to say, and some of you are just going to just glaze over and say, let me use a calculator. Is 7/8 more than 1 or less than 1? Less than 1. And if you multiply negative 5 by something less than 1, you get something less absolute value than negative 5. You probably get negative 4 point something, and your calculator can walk you right through that. But if I take negative 5 and I multiply it by something less than 1, then I get probably, I'm guessing, negative 4 point something. And what's negative 4 point something plus 6? I can't hear you. It's definitely a positive, right? I haven't done enough to the negative 5 to buff it down past negative 6 to the point where this is going to stay negative. So the green egg is negative 4 point something. And I'll show you how to do this on your calculator in a second. And when you add 6, this purple egg is definitely a positive, meaning 7/8 can stay. Okay. And again, I'll show you how to do this because I want you all to be able just to type it in with 100% confidence and know for sure. That little explanation is more for those of you that are kind of nerdy and want to do things in your head. I much respect for that. So then let's look at the purple one. What is purple? Like, give it to me as like a decimal or a mixed number. What is 5 over 2? It's 2.5, right? And if you multiply, go to the green egg up there, and if you multiply negative 5 by 2.5, I hope you agree that negative 5 gets more powerfully negative, doesn't it? If you want to be exact about it, it turns all the way down into negative 12.5. And what's negative 12 and a half plus 6? Negative. Enough said. That means that 5/2 gets one of these. So in my last 4 minutes with you, let me show you how you put this in a calculator. Okay. So let's say I'm sitting here taking my quiz on Thursday and I want to know how to do all that stuff that my teacher was just freaking droning on about. So what you're going to do is you're going to grab your calculator and you're going to type in -5, and then you're going to put parentheses, and then you're going to type in the fraction 7/8. And calculators don't have to have fraction buttons. Fractions and division are the same exact thing. So you type in -5 and then in parentheses 7 divided by 8. And then you close the parentheses and then you hit +6. Okay. So make sure you have your calculators on. I mean, you should have them every day in your backpack, but especially on Thursday, make sure you have one. And then when you type that in and hit enter, it's going to say something positive. So if you're grabbing your calculator and you want to give that a shot, give it a shot. And then for the other side of it, exactly the same thing. We're going to type in -5 times 5/2 plus 6. And this one, again, is a positive answer. What it is doesn't matter. It's positive, enough said. This one is a negative answer, enough said. So the answer to this one is just 7/8. Got it? So we'll try. I have the answers for this on Canvas, by the way. I'll give you another one just like this tomorrow. And then tomorrow, when you get to these harder ones at the bottom, you should feel more like buff and ready to go. So quiz Thursday, we're good. Okay. And you'll do it online. All right, sweet.